Today on page 81, we're going to talk about similar right triangles and the geometric mean. Okay. Okay, our objective remains the same, and it's to determine missing links using scale factors and ratios. Page 81. I'm going to say use the geometric mean. To determine side lengths. Okay, so what the geometric mean is, the geometric mean of any two numbers, I want to write that in blue. Grab the blue from here real quick. Geometric mean. So we're used to taking the arithmetic mean where we add everything up and divide by the number of numbers. The geometric mean is when we multiply two or more numbers together, then take the square root. Okay, so an example of that might be the geometric mean of 4 and 9. So if I were to find the geometric mean of 4 and 9, I do 4 times 9 equals 36. And I take the square root of 36 and get 6. So the geometric mean of 4 and 9 is 6. So if I were to multiply 4 and 9 together, take the square root, it would be 6. The geometric mean of 5 and 20 is, so what is it? If I would do 5 times 20, get 100, and I take the square root of 100, that would be 10. So the geometric mean of 5 and 20 is 10. Okay, and we're going to use this when we work with similar right triangles. The other thing that we need to know is the word altitude. And altitude is the segment perpendicular to the base that passes through the opposite vertex. So this would be, if I were to draw this triangle, the altitude of this would be right here. It's perpendicular to the base. It passes through the opposite vertex. This is the altitude. Okay, so what we're going to be looking at is we're going to be looking at similar right triangles. So if I were to draw a right triangle, let's see here, let's do There's my right triangle. And if I were to label A, B, C, and drop my altitude, okay, this actually creates 3 similar right triangles. And why are they similar? Here's why. So the first triangle is A, B, C. Okay, A, B, C. Now, a triangle that's similar to that would be triangle, well, let's look here. What's similar to A? What angle measure has the same angle as A? Well, A has the same angle as A. What angle is the same as B? B is my right angle, and I know both angles right here are right. So AD, B is similar to ABC. Why is this true? Well, it's true because they both share angle A, they both have a right angle, and therefore their third angle, angle ABD and angle C, must be equal. Another triangle that's similar to triangle ABC is triangle, well, D is similar to B, C is similar to C, and that leaves B to be equal to B. And you're wondering, which angles am I talking about? Okay, so C is equal to C, that's reflexive. D is equal to B in this little triangle right here, because they're both right angles. And B is equal to A because they're just the third leftover angle. We've talked about this before, where triangles add up to 180. So the 3 triangles are the purple triangle, the green triangle, and the blue triangle. And they're all similar to each other. So I can use that transitive property and say that since ABC is similar to both of these, okay? So, here we go. We're going to do some problems with these. So let's set up our first example. Okay, they want us to find the value of x. I can't use Pythagorean theorem because x isn't, I don't know CD or CB to find x. I don't know AC to find x. So I'm going to have to use this mean proportional. So what I'm going to do is I'm going to first set up which triangles are similar. So I've got triangle ACB. That's going to be similar to the smaller triangle over here. A matches with A. D is now my right angle, and that leaves this little angle up here, this little part, to be the same as B. I also know that triangle ACB is similar to triangle, well, B is similar to B, C is the same as D because they're both right angles, and that leaves me with C being the same as A. Okay. So what I'm going to do to help me see where my proportion is I'm going to set up a chart. And in my chart, I'm going to have the big triangle, the medium triangle, and the small triangle. Okay, so this is my medium. This is my small. Okay, and I'm even going to draw out the triangles so that they all match up. And I'm going to put the shortest side on the bottom. So here's CAB. Now I just match up with the medium triangle, which was the CDB triangle. So C matches with A, D matches with C, and B matches with B. And then in my small triangle, I have A matches with A, D matches with C, and C matches with B. Alright, so now I have three parts. I have the hypotenuse, the big leg, and the small leg. Okay. So the hypotenuse of my big triangle is going to be right here. So this whole length right here is 15. So I'm going to fill in 15. The bigger leg, CB, I don't know what that is. So I'm going to leave it blank. The small leg is AC. I don't know what that is. So I'm going to leave it just like that. Okay. Now my medium triangle, as I look at this, the hypotenuse is going to be across from the right angle. So that's CB, and I don't know what that is. The big leg is going to correspond to CB. So what corresponds to CB? DB. So what's the length of DB? That's 12. And the small leg is this leg that's left over. So that would be X. Okay. So the altitude is always the small leg of the medium triangle. Okay. The hypotenuse of my small triangle is AC. The big leg, well, what corresponds to CB? That'd be DC. DC is X. So this is also going to be true that, and the big leg of the small triangle. This is always true. Okay. And what's the small leg? Well, that's the last one that's left over. That's AD. So when I'm looking at this, I'm looking for something that will make a proportion. And essentially, if I don't know the values, they're not going to help me make my proportion. So I'm looking for a little box of numbers and the variables, and here it is right here. So my little box would end up being 12 over x equals x over 3. And now I can figure out what x is. 12 times 3 is 36. X times x is x squared. Take the square root. 6 is x. Alright, so a second example that we're going to see might look like this. Okay, so again, we're going to determine x, except for x is going to change locations. So again, I'm going to set up my similarity statements. Okay, so I have the big triangle, triangle ACB, and I'm going to make it similar. I'm going to decide what the similarity statement is for the smaller triangle. That's the word small. Okay. So A in my smaller triangle, it's not clear which angle goes with that. But C is the right angle in the big triangle. So D is the right angle in the smaller triangle. And then B lines up with B by the reflexive property. So B goes last for the smaller triangle. So C must line up with A. There's my small. Okay. Triangle ACB, now I'm going to make similar to the medium triangle. That's this one over here. Okay. So triangle, let's see here. A lines up with A by the reflexive property. D is the same as C because they're both right angles. And C must coincide with B in this case, this little angle C right here. Remember, it's only part of the angle. Okay, C must line up with angle B. They must be equal in measure. So this little angle right here. Okay, so again, I'm going to make my chart and try to look from that chart where my X falls and where that little box of a proportion falls. So you have the big triangle, and that's triangle C. The long side is AC, short side is CB. The medium triangle, so the medium triangle, D is the right angle, AC is the long side, so AD is the long side, and C is left. And then the small triangle. Again, D is the right angle. C lines up with A, so C goes up here. And I have B left to line up right where B was. Alright, so now I want to set up hypotenuse, big leg, small leg. And I want to remember that the altitude is always, let me get this to focus here. Not focused. There we go. I remember that the altitude is always the small leg of the medium triangle. So if I find the medium triangle, this is my small leg, and it's the big leg of the small triangle. It's always flip-flop like that. Okay, I'm sure you guys can see that pretty darn well. Okay. Alright, so the hypotenuse of the big triangle would be this length right here. It's going to be x and 5 together, so it would be x plus 5. Okay. The big leg, that's AC. I don't know what that length is. And the smaller leg is going to be 6. That's the word leg there. It's a G. Leg, small leg, L-E-G. Okay? In the medium triangle, my hypotenuse is going to be AC. I don't know what that is. The big leg is 5. That's this one down here, because again, the big leg in my big triangle is AC, so what lines up with AC in the medium triangle? That's AD, that's 5. So I'm using both the similarity statement, the picture, this notation. I could even use these pictures over here. I'm setting up a lot of different pictures and references, so I'm not confused on what part coincides with what part. And the smaller leg of the medium triangle, that's CD, but I don't know what it is. Alright, the hypotenuse of the small triangle, that's CB, that's 6. Remember, the hypotenuse is always across from the right angle, so I know this side is the hypotenuse. The big leg, well, that's the altitude, because remember that note up there, the big leg of the small triangle is always the altitude. And the